Hi everyone, and welcome back to the second video of the series. So in this video what I'd like to do is start off with a really basic program. Just get everyone on the same page on what a program is, what it's all about. So there's some learning objectives for this video, which essentially what we're going to say is by the end of this video, or by the time you're done this particular level, we would like you to be able to explain the three fundamental parts of a program. So the inputs, the processes, and the outputs. We'd like you to also be able to declare and access basic variable types, perform basic math operations in MATLAB, and then also display your answers on screen. So a lot of this you saw in the previous video, but we're going to just reinforce it in this video with a particular example problem. So let's get going. All right, so let's set up the problem. So I was recently flying on an airplane, and sometimes when you look at outside of the airplane window, what you can see down in the Midwest is big circles of crops that have been watered by a system, irrigation system, that has a radius on it. So it kind of became curious to me, could we calculate the area of each of those circles? And could we also calculate the perimeter, or the outside length of those circles? So that's the problem that we've got. And what we're going to do is we're going to cast this not into our calculator, but into this format that we're going to use for programming. So we're going to develop this flow, which you can see over here, this flow chart. And we're going to assign different parts of this problem to different parts of the flow chart. So at the beginning of the program, we're going to have to identify what are the inputs to solving this problem. Then the second part of this is going to be, what are the processes, right? And here I've written process 1 and process 2. What are the processes we're going to have to take to get the answers we would like to have? And then the last part of this flowchart is, what are the outputs? So what are the outcomes of this process? So what I'd like you to do is to just quickly pause the video and give this a try. See if you can identify the inputs to this problem. See if you can identify the processes you're going to have to develop. And then what are the outputs for this problem? So give it a try, just hit pause, and then we'll be right back. All right, so hopefully you've had a chance to take a look at this. So what I didn't give you was the information of how big those circles are. So from the air, they look relatively small, but when you're on the ground, they can be up to 800 meters in radius, perhaps even larger. So I'm going to use the radius of 800 meters. And that's something you would have needed to know in order to calculate those quantities we're interested in. So the quantities that we're interested in are the perimeter and the area. So we know, hopefully, that the area of one of these circles is pi r squared, right? So we have a process which involves mathematics to calculate the area. We also have a process to calculate the perimeter. So we're going to call those process 1 and process 2. And then once we have the processes, we can output the answer. So we can output the area and we can output the perimeter, which you can see here as outputs. When we're done this, we've finished our program. So this idea of a flowchart is really important. It doesn't just happen in computer programming. This is what happens in engineering, right? You have to identify your inputs, you develop the processes or the equations you're going to use, and then you come up with the outcomes or the outputs for the problem at the end of the process. All right, so what I'm going to suggest next is we're going to do a little retrieval practice. So last video, we had you try to follow along with me how to code up some basic variables and some very basic processes, right? So we did a equals 1, b equals 1, and a plus b equals c, which equals 1. So what I want you to do is I want you to take that idea, go into MATLAB now, press pause on this video, and create a program that has the inputs, the process, and the outputs for this crop circle problem. All right, so go give it a try. And after that, we'll go give it a try ourselves in MATLAB together. All right, so hopefully you've given this a try. And maybe you got there and maybe you didn't, but let's just go ahead and code this up ourselves. So here I am in MATLAB, and the first step I'm going to do, so if you recall from last time, is I'm going to create a new script. I'm going to create a new place to write these equations. And I would like it as a script so I can go through the sequence of inputs, process 1, process 2, and then outputs from that problem. So here in my script file, what I'm going to actually do is I'm going to start off by using comments to lay out my code. So I'm going to go like this, and I'm going to say the first step of this process or this code is going to be what are my inputs to the problem. Once I've done that, I'm going to say process 1, which is calculate the area. And then I'm going to look at process 2, which is to calculate the perimeter. And then finally, what I would like to do is output the answer. So I would like to output the area and the perimeter. So there's the structure of my program that matches the structure of the flowchart that I showed. So if we take a look at this flowchart again, here's my flowchart. I've created inputs, processes, and outputs. I'm going to go back to MATLAB, and you're going to see that the inputs, processes, and outputs structure is still there. So let's just go through and start declaring some variables. So remember, to declare a variable, we write the variable name, and then we say, what is the value we're going to assign to that variable? So here, I'm going to take 800, and I'm going to assign it into the radius variable. So I can call that variable r, or I can actually call it radius. And using radius would actually be a little bit better for other people to understand what the code's all about. I can then look at process 1, which is to calculate the area. So I'm going to say area equals, and this is where it gets a little bit complicated. I need to figure out whether pi exists in MATLAB. So how do I get pi in MATLAB? Because I can do radius squared as r times r, and hopefully I can see how that works. So I'm just going to come down here to the command window, and I'm going to just type pi and see what happens. And what you can see is when I type pi, I get 3.1416, which looks to be a reasonable estimate for pi. In fact, it's actually a pretty good one. So I'm going to say pi multiplied by r, and I could do multiplied by r again, but instead of that, I'm actually going to use the caret sign with a squared. So this will be to the power of 2. So I'm just writing out here, as part of this process, the calculation that I need to do. Similarly, I can do perimeter equals 2 times pi times r, right? So 2 multiplied by pi multiplied by r, which is my radius. And I need to be careful here because I've used the variable radius, which means I should use radius here, and I should also use radius here. And then finally, I want to output the area and the perimeter. So there we go. There's a set of steps that forms a computer code or a computer program that has inputs, process 1, process 2, and the 2 outputs I'm interested in. So let's just go up here and hit run. It's going to ask me to save this. So I'm going to call it video 2 example. There we go. And when I run this, what I see is in the MATLAB command window, I get example 2 being run. And it comes down here and it looks at the radius. It gets the area, right? So it does step 1, radius, step 2, the area, step 3, the perimeter, and then it does step 4, it produces the area back on screen, And step 5, it produces the perimeter back on screen. So what we can see is that every step of this program has been written out to screen. And as impressive as that might be to your friends to see all of these variables spitting out to screen, oftentimes we don't want to do that. So we're going to suppress the output by putting this semicolon on the end of the line, right there. So any line that we don't want to see the answer to, or the output on screen to, we're going to put a semicolon. So what I can do here is I can type CLC, which will clear the command line. I'm going to hit run. And you can see that now when I run example video 2, it only outputs the area and the perimeter. So what's nice now is we can suppress the intermediate calculations and intermediate steps of a program. So there's our example process or program that we've developed for the crop circle problem. So one of the things that you can try and do now is you can try to turn this off, right? Pause this video and do a retrieval practice where you start a new program and you try to do that program as a rectangle instead of a circle, right? So you can create a rectangular field and see what the area and the perimeter of those crops are. So go give that a try as some retrieval practice for this coding. All right, so hopefully you've had a chance to do that retrieval practice with a rectangular field. There'll be some more retrieval practice for this section in the links below. So if you go down to the description of this video, you'll find some more retrieval practice that you can do, or links to retrieval practice that you can do. What I just quickly want to do is I want to show you some of these other pieces, right? So we said we were going to declare variables, right? So let's just recap that. So we said a equals 1. What we do is we take the value of 1 and we insert it into a, right? So that's how we declare variables. So in this particular example, we have variables of area, perimeter, and radius. The other thing we started to do was talk about processes, right? So inputs, variables. Processes are, in our case right now, mathematical processes or equations we're calculating. So if I take a look at the processes we learned about multiply, which was this asterisk symbol. We learned about, I'll just write this next to here, multiply. We learned about the caret symbol, which is power. And then in the first video, we also learned about plus, which is addition. And you might guess it, right? But a subtraction sign, I should probably put these colons like this. This is going to be subtraction. Like that. Multiply is going to be that. And then let's get into division, which is going to be a slash like this, or a forward slash. We'll get into some of the more complicated processes that are used in MATLAB. So here we go. We've got a series of processes that would be commonly used by an engineer. So plus, minus, multiply, divide, and power. You also will use brackets to do the order of operations sometimes, or to force the order of operations a certain way. So be sure to also use brackets for order of operations, like this. And then another thing that a lot of engineers use are cosine, sine, and tangent of an angle. So these processes here are going to be in radians. And then if we go to the degrees version of those, we can say degrees, I'll just call this trig, and I'll call this radians trig. In degrees, it's going to be cos d of the angle value, sine d of the angle value, and tan d of the angle value. So with this series of commands, we're going to have some practice problems for you so you can retrieve and use MATLAB to retrieve these concepts and to strengthen those ideas in your mind, so that as you move on to the next video, you've practiced this and you've really crystallized it in your understanding. Because that's the more automatic you can make these processes, the easier it will be for us to build new processes on top of them. Similarly for inputs and outputs, the more we practice those, the better it's going to get. So let's just quickly jump to our summary. In summary, what we did today was we explained the three fundamental parts of a program: the inputs, the process, and the outputs. We declared some variables. Remember, we declared radius. We also declared area and perimeter as part of processes. The outcome of a process was put into that new variable. So we were able to declare new variables within a process. We're able to access those variable types. We performed basic math operations: multiply, power, addition. We also covered subtraction, division, multiplication, and the trigonometric functions. And then lastly, we talked about the semicolon for suppressing screen output or for displaying stuff on screens. So that's a very simple way of showing outputs on the command line so that someone else or yourself can see the answers to a problem. We're obviously going to dig into inputs, outputs, and processes a lot more in the next set of videos. So stay tuned, get ready for it, and come back for more. Looking forward to learning with you some more in the next video.